Hello everybody, I hope you guys are all having a great day today. It's about to get even better when you go to page 42 in your packet and you do some graphing systems of equations with me. So again, you're on video number 20, you're doing page 42, and you're listening to Miss Brat. So we are going to graph system of equations today. So it says a system of linear equations is more than one line graphed on the same graph. So this is why it was always super important to label every time you graph, because now we're going to start graphing more than one line, so we need to know which equation or inequality goes with which line. So when we're looking for a solution of a system of linear equations, it is the point of intersection. So when I look and see where two lines are intersecting or crossing or meeting, that is the solution to your linear equations. So points of intersection are the same thing as we just said solutions. Therefore, if we have no solution, that means the lines never intersect and are parallel. So two lines that never intersect are parallel lines, which are shown down here. And then a system of equations has infinitely many solutions when they are the same line. So we have some graphs down here as an example for you. So right here I have different slopes of two different lines. So the lines cross, or you could say intersect. So there is one solution. In the second one, we have same slope, different y-intercepts. But if we look, these lines are parallel, which means they will never touch. So the lines are parallel. Oops, I spelled that wrong. So there are zero solutions. And then a third one here, it says same slope, same y-intercept. So it looks confusing because it seems like there's only one line there, but the lines are the same, so it's one line on top of the other, so you can't really tell. So there are infinite solutions. Infinite meaning that it will go on forever. There is an infinite amount of solutions. All right, we're gonna flip to page 43 now. All right, so number one says to solve the linear functions. So we have both equations are already solved for y. So I can go ahead and just pull out my m value and my b value. So remember, m is always in front of my x. The invisible number in front of x is 1. I want to make my slope into a fraction. I can make any number into a fraction by putting it over 1. So my slope is 1 over 1. And my b value is the number all alone, which in this case is 2. So remember, b is where I begin. So I start at 2 on my y-axis. My slope is a positive 1. So I'm going to rise 1. And then it's over a positive 1. So I'm going to run 1 to the right. So both positive means up and to the right. So up 1 and right 1, I'm plotting as many points as I can fit. Up and to the right is the same as going down and to the left. I connect my points. I put arrows. And as I said before, this is why it's incredibly important to label, because we're going to graph more than one equation, so we need to know which equation goes with which graph. So we're labeling y equals x plus 2. All right, I'm gonna do the same thing in my second equation. So my m value in the second one is 2. Because it's in front of x, I can put that over 1 to make it into a fraction. My b is the number all alone, so the number all alone in this case is 1. I then am going to go, and b is where I begin, so I'm going to start at a positive 1. My slope is 2 over 1, so positive 2 tells me to go up 1. Positive 1 tells me to go to the right 1. So I up 2 and right 1. When I go up 2 and right 1, that's the same as going down 2 and left 1. So down 2, left 1. Connect my points. And I'm going to label, so this is y equals 2x plus 1. You are not done with this question. This is the part that everybody always forgets to do. So it says to solve, right? And on the front, we just said the solution means to find where your two lines or however many lines intersect. So my point of intersection was right here. You have to still write the coordinates for that point. So I went 1 to the right and then up 1, 2, 3. So my actual solution is the point 1, 3. My point of intersection or my solution is 1, 3. All right, in number 2, it says to find the solution to the equations. Y equals negative 3x plus 2 and y equals negative 3x minus 2 graphically. So if we take a look and you notice that these have the same slope, if you look on the front on page 42, we just said that same slope should have parallel lines. So when I graph these, I need to make sure that my lines do not intersect. So I'm going to start the same way. I'm going to pull out my m value and my b value of that first line. My m is always in front of x, so m is negative 3. I put that over 1 to make it into a fraction. My b value is positive 2. So b is where I begin. I start at 2 on my y-axis. Now I have a negative 3 as my slope, so I'm going to go down 3, and then it's a positive 1, so I'm going to the right 1. So 1, 2, 3. So 1, 2, 3, right 1. Down 3, right 1. Going down and to the right is the same as going up and to the left. I connect, oopsie, sorry. Hit my little gadget there. I connect my points, I put arrows, and I label away. Label, label, label. So this is the line y equals negative 3x plus 2. All right, we're going to do the same thing for our second line. So my m value is negative 3 because that's the number in front of x. My b value is negative 2. Remember, I want to make my m into a fraction, so I put it over 1. So b is where I begin. I start at negative 2 on my y-axis. Negative 3 tells me to go down 3, 1, 2, 3. Positive 1 tells me to go right 1. Down 3, 1, 2, 3, right 1. Going down and right is the same as going up, 1, 2, 3, left 1. Up, 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. So we want to make sure that when we connect our points, we do not intersect with the other line. We put arrows and then we label. So this is the line, or this is the equation y equals negative 3x minus 2. Remember, it's half a math test, half a reading test. So it said to find the solution. So my solution means where my lines intersect. They do not intersect, so my answer here would be no solution. You don't want to write 0 because we're looking for the actual solution. You're not saying there are 0 solutions, you're going to say no solution. All right, if we take a look at number 3, It says using the grid below, find the solution. So this time I have both my y's alone, but they kind of flipped the equation, so I'm just going to rewrite them. So I have y equals 2x minus 6, because we're used to seeing the y on the left of the equal sign. And then this is y equals 3 minus x. So we do have the y's alone, so we don't need to solve. So I'm going to go ahead and graph. So I'm going to pull up my m and my b. So my m in this equation is 2 over 1. My b is negative 6. So b is where I begin. So I'm going to start at negative 6. 1, 2, 3, 4, 5, 6 on my y-axis. My slope is positive 2 over 1, so I'm going to rise 2 and run 1 to the right. Rise 2, run 1 to the right. So up 2 and right 1, which is going to be the same as going down 2 and left 1. Connecting my dots, my points, don't ever call them dots, sorry. Points, coordinates, or ordered pairs. All right, and then I'm going to rewrite with the equation they gave me when I label. So 2x minus 6 equals y. I'm now going to graph my other line. So I pull out my m value and my b value. So remember, m is always in front of x. My m in this case is negative 1. I have an invisible 1 here. So it's negative 1 over 1. My b is a positive 3. So b is where I begin. So I'm going to start at 1 to positive 3. And then have a negative 1 over 1. So I'm going to go down 1 and right 1. So negative 1 tells me to go down 1. Positive 1 tells me to go to the right 1. Down and right is the same as going up and left. We want to plot as many points as we can fit. And then we connect our points. Arrows, we label with the original equation they gave us. So 3 minus x equals y. Half a math test, half a reading test. Find the solution. So the solution means to find where my lines intersected. So they intersected at this point right here. So in order to get there, I had to go 1, 2, 3 to the right. And then we didn't go up or down. So the coordinates at that point are just 3, 0. All right, moving on to number 4. It says to graphically find how many solutions there are to y minus 4 equals 2x and y minus 2x equals 4. So I need to solve these for y before I can graph them. So y minus 4 equals 2x. So I'm going to add 4 to each side to get the y by itself, because we always need to solve for y before we graph. I cannot combine these together because the 4 doesn't have an x. So my equation is y equals 2x plus 4. And then I'm going to pull out my m value and my b value. So remember, m is always in front of x. It's my slope or my rate of change. Put it over 1 to make it into a fraction. My b value is 4. So b is where I begin. So I'm going to start at 1, 2, 3, 4 on my y-axis. Positive 2 tells me to go up 2. Positive 1 tells me to go to the right 1. So up 2 and right 1 is the same as going down 2 and left 1. Connect my ordered pairs, arrows, and we label with the original equation. So we have y minus 4 equals 2x. All right, so now we need to graph the other equation, but before I can graph that equation, I need to make sure that I solve for y first. So I have y minus 2x equals 4. So I'm going to add 2x to each side. So I have y equals 4 plus 2x. Well, if I take a look at the line that we already graphed, it's the same equation. They just flip-flopped the 4 and the 2x. So my m would be the same, which is 2 over 1, and my b would be the same, which means that these two equations are the same. So when it says find how many solutions, it doesn't ask for the solution. There would be infinite solutions. Okay, so right now you are going to go and do page 45 and 46. So you're going to go and do page 45 and 46 on your own and then submit it under video 20. I hope you guys have a great day and message us on Schoology or ask us questions in class. Keep up the good work, everybody. Have a good day. Bye.